I'm Donnie Flood. I don't know why, but I'm doing the Zoom wave. I guess I'm just used to doing the Zoom wave now. Thanks for coming. I know this is like the last session before Kelsey Hightower, so excited to get you guys through this last one, hopefully leave you with some excitement. This is the first public talk that anyone's given on LiveViewJS, so excited and eager to get your feedback. We've got a lot to get through, so let's get started. I'm going to do some demos. I'm going to show some code. There's definitely code on here that you may not be able to see in the far back. You may want to move up closer to look at code. Feel free to sit back there, but just a fair warning. So real quick, what is LiveViewJS? It is an open source TypeScript framework for LiveView applications in NodeJS and Deno. That doesn't mean much right now. Why did I build it? Basically, over the last few years, like a lot of you, I've done a lot of single-page application development. Feeling, fairly disappointed with how that's gone. So I submitted the talk, a little spicy title, calling this the anti-single-page app framework. It's not really that. I'm more excited about LiveViews than I am disappointed in single-page applications. But hey, spicy titles get accepted. So. Quick overview of some challenges that I think face the single page application kind of ecosystem. This is not an exhaustive list, but some things that I've run into. First, we've got two stacks that you have to build if you're building a single page application, right? I'm not talking about a static site, but an application where you want to send data back and forth. You've got to build your front end application, React, Vue, Svelte, name your front end app. And you also have to build a back end application. Something REST API, GraphQL, something else, right? So all of a sudden you've got two stacks, and now you have to connect them. So the context switching is really costly. Language, you might have to switch languages. You might be writing, obviously, in the front end JavaScript, something else in the back end. And there's just a bunch of communications to figure out between the front end and back end. Now you can hire full stack developers. I claim to be a full stack developer myself. And those people can navigate these challenges, but they really can't solve this disconnection between the front end and the back end. Also, I think single page applications turn into really complicated code a lot of the time. So I think the spaghetti coefficient is monotonically increasing oftentimes in the SPA applications I've seen. Everything being one page actually causes a lot of complexity challenges that you have to face. There's a lot of client state management challenges to overcome. State synchronization, again, between the front end and the back end is very hard, can be slow, hard to optimize. And then, a lot of frameworks are shipping kind of where batteries are sold separately, right? So I think about this as normal things are hard, so form validation is hard. You have to find some form validation framework out there, learn it. Maybe it's not maintained next month, who knows? Submissions are hard, file uploads, kind of choose your own adventure, find something out there, hopefully it works. You might get previews, you might not. Drag and drop is hard. And then hard things that you want to add to, hard features you want to add, so real-time, multiplayer, stuff like that become really difficult. So those are some of the problems I've run into. Again, not exhaustive list. Maybe you guys have had an amazing time with single-page applications. And so struggling with things for a bit, and then one day I got a message. I'm on a Slack with some friends. Got a message from my friend Larry, who's actually up here. Thanks, Larry. Mentioned he started watching this video series on Phoenix LiveView. I had no idea what Phoenix LiveView. I've been hearing some mentions of LiveView out there. Said it was pretty cool. I should check it out. So when someone you respect tells you should watch some videos, I went and checked it out, and honestly, I was blown away. Phoenix LiveView is really impressive. I was super excited, very inspired. It just solves a lot of these problems where you have these two distinct backends or two distinct stacks. You bring those two things together. And what Phoenix LiveView really kind of made me understand is you could create single-page app-like user experiences with the ease of server-side rendered HTML. I know that sounds weird, but that's what it is. And so I got super inspired, and I started, learning about LiveView. I started going through the demos, watching the videos, writing some code, and these are some of the advantages that I think the LiveView paradigm kind of brings to front-end sort of software development. First of all, you got one stack. So there's no worrying about connecting the front end and back end. There's no REST or GraphQL API that you must build. You're actually just writing one kind of API that connects to the front end and connects the front end to the back end and serves your LiveView. There's no state synchronization challenges. There's only one place the state is, that's on your server, and pushes client updates. We'll get to that in a minute. So the inverse, I think, of the spaghetti coefficient is the pizza coefficient, which means it is easier to compartmentalize the code that you're developing. So each LiveView is its own server route and its own sort of like set of APIs that you're implementing. So it's a really small API. We'll show you that as well in a minute. Super small, super powerful, very well defined. And then LiveView ships with a bunch of batteries included features that make normal things easy and actually hard things easy as well. So again, form validation, right? Form submission, mapping kind of data models back and forth between forms and your data is really easy. File uploads with things like image previews, like automatic progress, drag and drop, constraints, all those things become easy as well. And the hard things are easy. So optimizing the size of the packets that are going back and forth between your server and browser, already done for you. The real-time multiplayer features are also, you want to add chat, you want to add presence, you want to add updates on one page, get reflected automatically on another. All those things are easy, and I'll show you some of that stuff. So that's why I got excited about LiveView. There was just one little problem, which was it was written in Elixir. And that's no dig on Elixir. It's a really cool language, super amazing VM. It runs on top of the Erlang VM. I just happen to really like TypeScript. And I didn't want to learn Erlang. I didn't want to write Erlang. The other thing is that from an ecosystem standpoint, Erlang, this is based on like the Stack Overflow survey. Erlang is popular with about 2% of developers, while obviously JavaScript, TypeScript is popular, well maybe not obviously, is popular with about 65% of developers. So there's about 30 times the developers who are doing TypeScript and JavaScript compared to Elixir. And I was, again, more inspired probably by Phoenix LiveView than upset about, the SPA frameworks. And I wanted to bring this LiveView concept to the JavaScript ecosystem. So as I was, kind of learning Phoenix, it came to me that LiveView is actually a protocol. So it doesn't have to be limited to the Elixir ecosystem. In a sense, there are really clear messages that go from the client to the server. It's just JSON. Events get pushed up. The server runs through the state kind of machine. We'll show you that in a minute. And then sends back diffs to the client. The client applies those diffs. So it's actually a pretty disconnected client and front end, back end kind of protocol. And so what I thought to myself was we could actually write LiveViews in TypeScript, theoretically. And so that's how I nerd-sniped myself into writing LiveViewJS. I do think that might have been Larry's plan the whole time, but we'll have to ask him over drinks later. Real quick, I do also want to give credit to the LiveView team. I would not be here without them. The concept of LiveView came directly out of the Phoenix LiveView ecosystem. The reference, I consider the reference implementation of LiveView to be the Elixir implementation. There's no real spec. And we actually use the Phoenix LiveView client JavaScript to run LiveViewJS. So there's actually, we didn't want to reinvent the wheel. We're built on top of this battle-tested, productionalized, production-ready, like tens of thousands of production apps are running the same front-end JavaScript that we are. So again, I wouldn't be here without Chris McCord and the Phoenix team. I don't know any of them. If anybody here knows them, would love an intro, but just wanted to give credit where credit is due. Okay, so I've talked a lot. We haven't seen a LiveView yet. So what is a LiveView? Real quick, it is a server-rendered HTML page that connects to the server over a persistent WebSocket. The client automatically listens for user events, send those events to the server. Server routes those events to the live view, runs the lifecycle methods, we'll show you that in a minute, recalculates the view, and then sends optimized diffs back to the client. The client automatically applies those diffs to the DOM, and that's sort of how it works. LiveViewJS makes that most of the complex parts of that just transparent to the developer. So you have to write your live view, and then the LiveViewJS framework automatically routes your events, automatically handles rendering your methods, calling the lifecycle functions, automatically sends the diffs back, automatically calculates the diffs. So it makes kind of writing these SPA-like user experiences super straightforward for the developer. Cool, let's see some live views. This is going to be a little awkward because I got to look over here to the right, but all right, so here's a live view. We've got a little toggle button. We're going to toggle between text and emojis. Pretty straightforward, nothing super crazy. All right, we got a counter here. Classic canonical-like example where you hit some buttons, some numbers are updated. Let's see what else we got. We got a live dashboard. So this dashboard just updates every second. It's kind of random data, but this is super straightforward in LiveViewJS. So it's just generating some code, automatically sending that data to the client. Here's a little search example. So I happen to live in Denver. So this is just a Denver zip code that you can look up a set of stores. So that's a live view as well. So all of this is happening. All right, yeah, let's close these. This is the little awkward part. Sorry, guys. OK. Oh, shoot. And that's when I lost my speaker notes. All right. And we're back. Sorry about that. OK. So you got to see some live views there. Now let's take a look at some of the code. So you saw this example, hello world. This is when, if you're in the back and you can't see the code, feel free to move up. This is like the super basic live view example, right? We've got 3 methods defined here that are part of your live view. We've got a mount method, which is called when the HTTP request first happens and when the socket connects and re-renders. We've got a handle event method, which basically takes your click event in, updates the context of your live view, which is the state. And then we've got a render method, which takes the context, renders an HTML page. And that's how you implement just that toggle view that you saw before. So pretty straightforward. And again, this is like what you write as a developer. So you don't have to think about connecting to the WebSocket. You don't think about rendering, diffing, applying that diff to the DOM. This is your this is the code you'd write for that example. Next counter example. Similar method layout. We've got mount, handle, event, and render. In this case, we've got a couple of different events that are going. One's called increment, one's called decrement. But overall, it's the same kind of model, right? You render your HTML. In that HTML, there are events that are defined by the bindings, phx click, one for decrement, one for increment. Those events get routed back to your live view, update the context, re-render, all that stuff. So as I mentioned, LiveViewJS and LiveViews all run on the server. So 0% of the code that you just saw was shipped to the server. The only thing that was shipped to the server was the HTML that was rendered, and that's it. And diffs that are happening as the user's interacting with that HTML. So again, super, this is obviously oversimplified, but the way it works is the client watches for events. Once you've annotated your HTML with those bindings, it'll automatically listen for click events, other events, send those events to the server. LiveViewJS automatically knows where to route those events, what LiveView to route it to, automatically runs the lifecycle methods, mount, handle event, some other methods you'll see in a minute, passes that to render. Render re-renders the page. LiveViewJS takes the diffs, or takes the render, compares it to the last render, calculates the diffs, ships those back to the client. Client applies that. Again, all transparent to you as a developer. All right, we're gonna try to do this. We'll see how this goes. But I think it'd be cool to show you just the diffs real quick. So let's see here. All right. So this is the socket traffic that's coming back and forth between LiveViewJS and the browser. So you can see our count is 0, now our count's 1. You can see the message coming back and forth. And this right here is actually the data coming back from the server. And you can see, I don't know if you can see that very well in the back, but basically what you're seeing is inside this diff JSON response, it's basically saying I really just want to set that number 2, or that where that value was a 1 previously, I'm just going to set it to a 2 now. So I know that's a little hard to see probably from the back, but just wanted to point out that's sort of like the amount of data that's coming back. It's just saying I've got to apply this diff to this part of the HTML tree, and the client automatically knows how to apply that to the tree. Let's look at the dashboard. Is a little more fun to look at. There we go. Sorry, it's a little awkward. Network page again. All right, let's lower that down so you can kind of see at least. All right, so now you're seeing kind of in the bottom there, every second you're getting a new diff come by, and that's only updating. Yeah, there we go. You can see at least a couple of these pieces of data. So you can see, this diff is coming. It's only changing the values for a couple of different parts of the tree, and those are just automatically being applied by the client. So that's a little bit. There's a lot more that goes into that, but just wanted to show you guys the diffs coming back and forth. All right, so again, your LiveView lives on the server. It doesn't ever get pushed to the client. All we're pushing is diffs, which is pretty cool. Anatomy of a LiveView. So there's only 5 functions in a LiveView that you need to worry about when you're a developer. We'll go over these in a little bit more detail, but mount, which is called on initial rendering on the HTTP request and when your WebSocket connects. And that just basically used to initialize and configure your LiveView. Renders, we talked about this one, just you need to output some HTML. LiveViewJS takes care of doing the diff and kind of passing it back. And then there's 3 different handle methods. And we'll go through each one of these. You saw handle events. That one handles any user events that come in from the browser. And there's a couple more, handle info and handle params, which I'll show you some examples in a minute. So we talked about mount. LiveViewJS calls this automatically, called once per cycle for LiveView load, once on the HTTP request and once on the WebSocket connection. It really just initializes the contacts. And what's cool about this is any HTTP session data is actually automatically pushed to your LiveView. So in the mount function, you get all the data for that user's session. So that's how you actually transition data from your HTTP session to the LiveView itself. So yeah, there's actually quite a bit of detail on LiveViewJS.com if you're interested more in the life cycle of. I'm not going to get too much into the life cycle of LiveViews, but there's a bunch of sequence diagrams and content on LiveViewJS.com if you want to check that out. We talked about render again, real quick. Automatically called by LiveViewJS. It's past the latest state or context of your LiveView. So after all those handle functions are called, you always get the latest context in your render, and your job is to render your HTML page. It also passes some kind of metadata with it, some CSRF token, the current page URL, some other helpers that you'll see in a bit. And it does not send back any HTML. The LiveViewJS takes care of sending only diffs back. slight correction. On HTTP, it obviously sends back HTML, but everything on the WebSocket only sends diffs. We saw handle event a couple times as well. So user events on the client side are routed here automatically. Typically, you're updating the context based on these events, and otherwise, reacting to the data passed into you, the user events. Okay, this is one we haven't seen yet. I'll show you a demo of this in a minute, but there's another handler here called handle params. And so this is called anytime the URL changes for your live view. So, and also called on the initial page load. So if you have a URL coming in that has some query params on it, for example, this is automatically called, again, by the framework, and allows you to update your context based on any URL parameters or any hashtags or whatever part of the URL you want to process. Cool, let's look at some examples here. So we've got two examples. So right now you can see we've got no URL params. This is just like an example food bank donations app. We're just gonna sort here by clicking on the column. You can see it added some params here and sorted by ID our list of items. Let's sort by days until expires. You can see we've got a bunch of stuff that are going to expire in the next day or so. And again, all that was happening just by changing the URLs, the page URL, and the query params in the page. The other one we have here is just a kind of maybe a tab demo, right, where we've got these different buttons or tabs. Click on them. You can see the ID in the URL is changing. You may not be able to see it in the back, sorry, but basically we're setting different IDs on the URL, and the page is being re-rendered automatically based on that. So that's what, all right, yeah, I gotta close these, sorry. All right, so those are some handle params LiveView examples. Just to go over the server code real quick. We're looking at the handles param function. It's called when the URL changed. And what's passed into that function is a URL, right? And what we're able to do in this case, on line 4, we pull the ID search param out of the URL. We look up the server, and then we update the context using the socket data signs with that server. The rest of the render loop runs, sends the diffs back, and your page gets rendered. So pretty straightforward. Handle info is actually a really powerful function. And this is the last. We've covered everything else is the last one. Number 5. I know it's a big API to learn. But this is where server-side events actually get sent to your live view. So server-side events happen in really a couple of different ways. One is you can have another function called sendInfo, which is on the socket, so socket.sendInfo, and pass an event to that function directly. And it's a good way to offload any asynchronous requests that you want to make. So let's say you get a click on the user or a search, for example, in the handle events lifecycle method. You can call socket.sendInfo and send that event over to handle info, continue through rendering, maybe load a loading screen or something, and then run that search method. When that returns, update the socket, and then the rest of the render happens. The second way to get our handle info is called is typically through pub sub messages. So I'll show you some of that in a bit, but basically you can, built into LiveViewJS are pub sub methods. So you can subscribe to any topic you want, and when you subscribe to that topic, those messages that are sent to that topic get sent to your handle info callback. And so that's a good way to, we'll talk about this later, but real-time multiplayer kind of features are usually driven through this handle info pub sub methodology. Cool. All right. We saw the sales dashboard one, so just to, here's how that works. We've got, just showing you two methods here. We got the mount method, and in this case, we have on line 5, we've got this kind of helper function that just repeats a function in an interval. It's called socket.repeat. And inside that, we are calling socket.sendInfo and we're passing in just a tick event. And that basically is kicking off the handle info event. Every time that handle info event runs, it's just pulling in random data. In this case, it could obviously be pulling in your actual data. And then the render lifecycle runs, and your page gets updated. Cool. Let's talk about type annotations. So I'm a TypeScript developer. I love TypeScript. I like when libraries help me help myself. And so in LiveViewJS, we actually highly recommend you write your code in TypeScript. You can take advantage of TypeScript. In this case, I'm showing a couple examples where you can pass in the type annotations into the create LiveView function. So this is how you create a LiveView, just a helper function. In the first example, you're kind of like inlining the types there's 3 different types you can pass in. One is the context, right, the shape of your state. The second one is the set of events that you expect to come into your handle info method. And the third is the set of infos, right, the kind of server events that you expect to come into your handle info. So in the top case, we're just doing it in line. Here's the shape of our context. We're expecting 1 refresh type event coming into handle event and 1 tick event coming to handle info. The second example is just you can define your types elsewhere, right? You can define some other types above, and then just pass those types directly into the type annotation as well. So I don't know if you're a TypeScript geek or not, but we try to make it easy. This next slide is just showing you, here's a case of like, you are making some, the TypeScript compiler points out errors when in your code if you actually provide us with type annotations. So in the first case, on line 12, you can see the little squiggly maybe underline, but we've defined the shape of our context to be a count, that's a number. And in line 12, we're trying to assign a myCount property to that to the socket. That's not going to work. TypeScript tells us. The other example, again, it's a little hard to see, sorry, but on line 24, we're trying to look for a type called reset as an event coming in. We haven't defined that type in our type annotations above, so TypeScript tells us you're doing something wrong. So just wanted to say, this is a library that tries to help you write better code. And by providing some type annotations to your LiveView, we can help point out problems you might have. Cool. It's going great. First public talk. All right. User events and bindings. There's 4 types of the more main types of user events that kind of the bread and butter of LiveViewJS. There's clicks, forms, keyboard input, and there's focus blur events. There's some other bindings and sort of like things you can do pass in with these events. There's value bindings. There's rate limiting bindings. We can actually throttle and debounce really easily in LiveViewJS. So I'm not going to cover that today, but a ton of documentation on LiveViewJS.com. So let's first start on So those are the types of events. In order to capture those events, you need to annotate your HTML with these bindings, which are also known as attributes. So in order to add, basically you can add any of these bindings. I'll go over a few in a minute here to your HTML elements. When those events happen, the LiveViewJS library automatically recognizes that and then ships those events up to your server. So super basic, but this is how the click happens on sort of that first dark background there. We've got a button. It's annotated with the phx-click binding or attribute. And the value of that attribute is set to increment. So that just means when a click happens, I'm going to ship an event called increment up to my server. Okay. The phx part of this comes from Phoenix LiveView. So again, I mentioned this earlier. We are totally built on top of this amazing, library, battle-tested library that Phoenix ships. So we didn't reinvent the wheel, we're just using theirs. And by default, all of their attributes are prefixed with phx. You can easily change it. It's something that's changeable. I just went with the defaults, but just wanted to point that out. Thank you, Phoenix LiveView people. And when that click event happens, your handle event method will receive this this sort of JSON payload. Key events, right? So you want to capture keyboard events. This is an example of a div where if your key down, if you press the key down on the arrow up button. Sorry, I probably should have had a better example here, but that's what this first dark background example shows is when you hit the arrow up button, basically that key event will be shipped to your handle event method, along with the arrow up key that you pressed. So you can filter out by key, phx-key, or you can just capture all the key events and then filter them in your server if you want. So that's how that works. Pretty straightforward. I think maybe another batteries included, like actually capturing key events is pretty nice and easy. You just annotate your HTML. All right, battery included, forms and change sets. I'm excited about this one. Change sets are amazing. All right, we'll get there in a minute. First, there are two form bindings, only two bindings for forms. There's a phx-change binding and a phx-submit binding, okay? Change is when any form input is updated in your form. And you can, to be clear, you can like rate limit that. So if you want to capture just when someone stops typing for a second, I'll actually show you that later on. So it doesn't have to send every event, but so when any form event is updated, phx-change, that's called, whatever event is passed to your server. phx-submit is probably obvious. When your form is submitted, it sends an event to your server. Both of those events also get all of the form input data that are part of your form. So you don't have to do anything about your, to send that data. It's automatically all shipped up there for you. Cool. So here's some code. First window there is, again, you're just annotating a form with phx-change, phx-submit. When change happens, a validate event is going to be sent with all of your form data. When submit happens, a save event is going to be shipped with all of your form data. And then you can do what you need to do. And I'll show you change sets here in a minute. But typically, you're, on the change event, you're validating your form, right? And on the save event, you're validating and doing whatever you need to do, mutating your data. Cool. All right, change sets, again, stolen directly from Phoenix LiveView. I think this is, it might be actually Ecto, which is their kind of data library. But it's completely imported from them. And I don't know of anything in the JavaScript ecosystem that I think is as cool. So highly recommend this part of really everything, but this is pretty cool. What it does is it allows you to map data, basically map form and data, a model between your form and back. So automatically does that parsing and mapping and error checking, connects it to your form, automatically shows errors when your form's invalid. I'll show you an example. It's built on top of this amazing TypeScript library called Zod. I don't know if anyone's familiar with Zod, but it's amazing. It's one of the only dependencies that we built on top of because it really drives this feature. Zod is a TypeScript first schema validation library, which is super easy to learn. And I'll show you some code. You'll be experts, well, whatever, beginners at least in 1 minute. And again, this is like designed to work directly with forms. So it makes mapping data between forms and data models super easy. Cool. Let's look at some code. All right. This is just a little baby form, but it's imagine I have like my library and I want to put all my books in the in the library. So here I'm going to do The Hobbit, and obviously that's oh, I hit enter too soon. Boom, we've got our validation coming back saying, hey, this must contain 4 characters. I'll show you the code in a second. So I need, so I am also debouncing this. So after I stop typing for 1 second, it'll automatically try to validate again. So I'm just going to type JR, and you should see, oh, 4 characters, right. There we go. So stop typing, and it automatically sent the, called the PHX change event and sent it up to my server for validation. So finish, that's not how you spell it. So there we go. Now my form was automatically validated. When I hit submit, the save event was called. Same validation functions were run and automatically, well, not automatically saved, but then I could continue on with my life. OK, I'm going to close this. Cool. So here's the code. This is just the kind of defining the schema first and the change set itself. So pretty straightforward. We've got this book schema, right? This is the Zod part. You have an object. It's got these 4 properties: ID, name, author, checked out, which you saw. ID is just by default going to be a random string. Checked out is by default going to be false. And then name and author, you can see we've got a couple of kind of constraints there. Name needs to be at least 2 characters up to 100. Author needs to be 4 characters up to 100. So there's a lot of other validations you can do in Zod: email, phone number, all that stuff's built in. And this will all work with any of those configurations. After we define that schema, a schema is basically what Zod parses to turn your JSON data into, or the JSON data to validate it against that schema. We're also going to infer the book type, which is just helpful in typing our change set. So the last line here is this new change set factory LiveViewJS function. So we're going to pass in the schema. We're going to type it as a book. So now we have this change set factory for a book. And we're going to use that to do our validation and form kind of submission code in the next section. Cool. So here is, this is the render function. So this is how the form gets rendered back or rendered in your LiveView. Again, a little hard to see, but you can see we've got a couple of helpers here. Form for online. I don't have this numbered for some reason. Where is my thing? OK. So we've got a form for helper here. We've got our PHX submit and change events defined. Here we've got a text input. This is where the change set part comes in. We've got a text input. We're passing in a change set for that book. That change set has whether that particular, well, has all the data about the full model. And then using the name property, it's going to look up the name data, whether it's valid or not, and sort of set that back to the text input. The error tag will only render if there's a valid error at that property. There's a lot of cool TypeScript stuff in the background here. But this is how easy it is to connect your change set to a form. You can see this is the PHX did bounce part I was telling you about. So after I stop typing for 1 second, this automatically knows only send the form field, or only send the PHX change event once this input has been debounced for a second. Then we got our, author field as well, and then we've got our submit button. So that's pretty straightforward code. This is the handle event method, right? Again, every user event goes back to handle event. In this case, these are the, cut a little bit of code out of here, but these are the validate method or event that's called when PHX change happens, and the save event when PHX submit happens. And the first part, line basically 5, 6, 7, all we're doing is just using this book change set factory. We're passing in the event data, which has all of the form field data automatically, and we've defined that. We've actually defined that type elsewhere, but it's automatically part of that event. And we're setting the change set data back into the context. And so basically, when all those validation errors occurred, that's the one line that we're calling to show validation errors to our users, which is pretty sweet. And then the save method, or save event here, it's a little bit more work. We're just checking to see on line 13 if that change set is valid. If it is, cool, let's save that book, add it to our database, and then clear the form. That's what the kind of line 18 does, just resets our change set. And if it's not valid, we're just going to pass back that change set and make people fix their errors. So that's how basically, that's how easy it is to add form validation and change sets to your LiveView. All right, awesome. Latest, this is what I wrote this a little while back. We've got file uploads now as a batteries included feature. It's pretty sweet. We've got automatic image previews, upload progress, drag and drop support, and constraints. So what file types you want to limit people to upload, file size, the number of files that they can upload, all that stuff. Pretty, all really easy to set. All right, demo time. Cool. So here is our photo groups app. We've got some files here that I've already kind of preloaded. So in this case, oh, actually, I should show you first the constraints. So in our photo group app, we only want to limit up to 3 photos to be uploaded at a time with a max of 5 megabyte per photo. And it's also photos, so it'll only allow image uploads. So that's kind of what we've got here. Let's say, I don't know, I want to upload a kitten. Here's my image preview for that cat. I've got the progress bar, which we haven't uploaded the image yet. Got a little remove image if we want, so I can click that and that image goes away. So all this is built in pretty easily. Let's go back to our cats and look at Fluffy. Let's try to get 5 files uploaded here and see what happens. All right, so we got a couple errors here. We've got too many files, and we've got something that's too large. So this happens to be a file of my dog, which is larger than 5 megabytes. So we can't upload that one, so we're going to remove it. We still have too many files. You can see all that's updated automatically. So I'm going to take this first coon cat, I think, and just remove that. And now you can see our errors have gone away. I'm going to try to submit this and see what happens. All right, so all of our images, all the image data has actually been uploaded, but we still had a validation error. We need at least one character in our photo group name. So let's name that Fluffy. Nope, Fluffy. And then we should be able to finish our stuff. Cool, all of our files are now validated, or our form was validated, so we can actually take those files, process them, and now, in this case, we're just re-rendering the photo group back out at you with some numbers. But I'm going to show you some code. That's going to be how easy it is to do that. All right, cool. So constraints, right? So we talked about limitations on the number of entries, the number of the file size, and the file type. So that's all in this allow upload socket function here. We're basically naming our upload config as photos, which we use kind of elsewhere, and then setting the file type extensions. We can also support MIME types, but setting the file type extensions here to a set of photos images that we want to allow. We've got 3 files maximum per upload, and then our max file size is 5 megabytes. And all that data is actually passed back into your render function, so you can update your HTML as if your constraints change, you could automatically upload your HTML. All right, how are we doing on time? We got about 10 minutes, so I'm going to rush through a couple of things. Okay, quick image preview example. So this is how the image previews works. We've got our meta. In our render function, we have this meta object. We're getting our uploads from that. And then we're going to map through the entries and call this render entry helper function. And inside that on line 13, you've got this helper tag called live image preview. You pass in your entry, and that just renders your preview image. So it's literally one tag. to get image previews. This is the upload progress. So again, it's we're getting our uploads object from our meta object that's passed into render. We're going to get our photos out of that and the entries out of it, map over those, and then each entry automatically has a progress property. And as those files get uploaded, the progress gets updated, and you can update your UI. So it's really simple. In this case, we're just showing a progress meter and outputting the percentage of progress so far. Drag and drop, also a one-liner or less than one-liner. In this case, line 5, we've got this PHX drop target and we're passing in the uploads photos ref. That's it. It just turns your div into a draggable target and automatically knows what upload config to put your entries into. So it's just like, how could it be easier than that? I just don't know. Cool. All right, last topic, and then we'll do some questions. So real-time multiplayer, batteries included. We natively support real-time multiplayer user experiences. It's built on top of pub/sub primitives. We've got, so there's like minimal effort by you. There's basically 3 types of pub/sub implementations depending on your runtime. So there's always like a single process pub/sub that's just kind of basic testing local stuff. We also have a Redis pub/sub implementation for Node.js, and we have a broadcast channels implementation for Deno. So if you're into Deno, or you understand Deno, it's actually a really cool part of Deno deploy where broadcast channels is actually a kind of a global topic queue that you can post messages to and get and subscribe to. So that's what we're built on top of. And these, there's really 2 things that that enable all real-time pub/sub stuff, which is one, broadcast, which is the method that you essentially call from your pub/sub implementation to push messages to a topic, whatever JSON topic or message you want to publish, and then subscribe is how you subscribe to messages from that topic, and those messages always get pushed to your handle info method that we saw before. So that's basically how it works. Super easy and really powerful. The framework automatically sort of manages all the routing stuff for you. So once you've subscribed in your socket to a topic, LiveViewJS will make sure it gets there. Assuming it's obviously if you're running multi-process, you need to be using one of the multi-process implementations. But that's how it works. All right. So I've actually showed you some real-time examples already. So let's do this. All right, I'm going to pull this one down, and then okay. So we basically have two tabs. They're both loading the same live view. I don't know why you'd need a counter that's real-time multiplayer, but here's a real-time multiplayer counter, and I'll show you the code. Actually, I'll show you the other examples first, and then I'll show you all the code. Okay, so you guys, let's close that one actually. All right. It's annoying going back and forth, but we'll get there. Okay. So we saw the my library kind of example as well. Here you can see I'm just going to check out this book, and it's automatically updated in the other live view. So pretty straightforward. We got to add another book, foo, bar. Oh, right, it needs to be 4 characters. There you go. We added a new book. It automatically got pushed to both tabs. And let's do one more, which is our photos. Okay. Oops. So in this one, we'll choose some more files. Oh yeah, that one's too big, sorry. It's hard to see over here. Oh well, whatever. cool. And you can see those get uploaded as well. So, all right. I know we're running out of time, so I'll speed this up. That's actually pretty much it. So, for the just real time socket.subscribe, we've got this topic that we've now subscribed to called counter, and then we're going to publish broadcast counter events in the handle event method. For books, same thing. We've got a socket that subscribes to the books topic and then publishes, I know I'm going fast here, but publishes the events back using broadcast to the books topic with the type updated, and then the handle event updates the example. So that's how easy it is to do multiplayer real-time stuff. There's lots of other topics that I did not have time to get through, which are all available online. Lots of cool stuff. There's actually a LiveView native project now. You can do LiveViews in iOS. We have live components, lots of other lifecycle stuff, security. So I know we're out of time, but I do want to say thank you to the Strange Loop organizers. Awesome. Thanks for having me. Thank you all for listening to my first public talk. Hopefully it didn't go too bad. And special thanks to Larry for nerd sniping me into LiveViewJS. If you want to learn more, happy to talk. There's like 25,000 lines of documentation or words of documentation on LiveViewJS.com that I wrote. Would love to answer any questions. There's a couple of socials on there to follow as well. Any questions real quick? Yeah, great question. It's actually one of the topics I didn't get to. We have this thing called a JS command, which is part of it's actually part of the LiveView new release that came out for Phoenix as well. But it allows you to define transition classes that you want to make and target specific DOM elements. It also has a bunch of kind of utilities for like hiding different DOM elements, showing them, toggling between them. So there's the JS commands is what you're looking for. Happy to. It gets shipped along with the diff. Yep. Yeah, with your event. Yeah. And yeah, go ahead. Oh, yeah. I'm not familiar with Caldera, so I don't know. The question was how is it different than Caldera? I don't know. Maybe I should check that out. Do you have an answer to that?
I've just seen that there are like a handful of JavaScript LiveView.
I would guess, I'd wonder if any of them are compliant to the actual LiveView sort of spec, right? Are they reusing the same library that Phoenix LiveView is? I don't know. Next question.
Yeah, so in the React world, we have like the browser code, like you hit Command R and you kind of like refresh that as a unit, so there's just sort of like consistency there or whatever. In terms of log sessions and like, I'm pushing out a new version on the server, like,
yep.
It seems like that could be a problem area. Like, how do you not have a step change or like lose user state, or is the thought on versioning smoothly, or is it left as an exercise to do?
Yeah, that's a good question. So all the state is always on your server. So assuming that you're actually, saving the state on your server, updates shouldn't really matter. Theoretically, you could run into like an impedance mismatch, right, where you like have the server with different event handling, or you're renaming stuff. So yeah, I don't know. I haven't run into. I'm like, this is so new. I haven't run into that yet, but I think it's a really interesting question.
It would be event-driven. Like if I have to open and I
yep.
click on a button and suddenly like the table totally changes. Is that right?
It could. Yeah.
Last thing, CSS and styling. That's all static.
Yeah, all whatever you want, right? So you want to use Tailwind, great. You want to, do your own CSS, and it's all just HTML. So however you want to apply, CSS to your HTML, that's how you do it. Okay, we're out of time. Thank you so much. I would love to answer any more questions.